Have you ever wondered how a computer can recognize shapes? Well, one way it can do that is using the Hough transform. And if we wanted to recognize this yellow circle inside of an image, say we took a screenshot and then we started processing this image, um, we could start by trying to isolate the yellow areas. And the way we do that is through using hue, saturation, and value. A computer likes to store colors with three numbers. How red is it? How green is it? How blue it is it? Um, but we want to think more the way our brains do, and our brains think more in a hue type way. So this color wheel represents hue, and we can take a slice of pie out of it and say any hues that are in this range, we want to keep those, and anything else, let's throw away. So if we do that, we're going to end up with a binary image of black and white. Yes, it is yellow, or no, it's not. And this is a really simplified version. We're down to just a 10 by 10 grid. Whereas, of course, the screenshot that we took is going to be hundreds or maybe even thousands of pixels wide and tall. But for understanding how it works, it's nice to simplify. So we've got our black and white simplified image. And if we simplify even further and we only think about this fifth row, we've got that down underneath here, then we could also think of it as ones and zeros. So we could say the white cells are zeros and the black ones, or our yellow ones actually, are ones, although it's usually the inverse, but don't worry about that. Then we could also do operations on this, like taking the derivative. And if you're familiar with calculus, you probably know that there's some issues with that, but we're not going to worry about that today. We're just going to go through and say, what's the difference between this cell and the one before it? And there isn't one before it, so we'll just call that 0. So difference between 0 and 0 is 0. Difference between 0 and 0 is 0, and so on until we get to this change. And the difference between 0 and 1 is 1. And then the difference between 1 and 1 is 0 again, no difference, until again it changes back. So what have we done by doing that? Well, we're kind of, if we did that for the whole image, we're kind of finding the outline. Now you might notice we didn't do a very good job finding the outline of this block, but if in addition to doing that process for each row, we did it for each column, then we would find these horizontal edges as well. And that's usually how this is done. There's more complicated ways of doing it too. But if you're interested in that, then check out canny edge detection. It's a really interesting process. But the nice thing that we're going to have is we're going to end up with an outline of our solid circle. So we started with this solid filled in thing, and now we have an outline. And now I want to go to something a little bit higher resolution. Let's look at 100 by 100 instead. And we've got our perfect outline. And now we're going to do the really interesting thing, which is the Hough transform. And how that works is we're going to start with we'll start with our first lit up pixel. And what we're going to do is we're going to go to the origin, and we don't know where the center is. So let's say if this was the center and this pixel was on the circle, then that circle with center here would have a radius of, I'm going to guess about 30 here. Since it's 100 by 100, we're going to say roughly about 30. And then we'll go to the next pixel over, still up in this corner here, and we'll ask the same question. What if the center was here instead? And again, that same first pixel was on this new circle. Then what would the radius be? And maybe it would be 29 now, because we're getting closer. And we would keep going across the entire grid to try to imagine what each circle would look like. And if we did that, I made a little animation to explain what that would look like. So we're voting on each place here. Now we're into our second row and we're taking all the votes. And each one of these points represents a different hypothetical circle with a different center and a different radius. And eventually, it takes a while, but we'll end up with a plane. And the plane for that first pixel is going to look like this. Now that plane alone doesn't really tell us too much. But if we did this for other points on that circle, we're going to end up with more planes. And remember, the way we describe this is taking votes. So we're voting on if a circle had this center, then it's going to have this radius. So each point that we have along that circle is going to vote for each potential center, and then what would the radius be for each one. So what we end up having, a good way to envision this is a 100 by 100 cube, 100 by 100 by 100 cube, and and each time we're voting for, if we think of that, the bottom of the cube, that's the image that we're starting with, and we're voting for, on each one, our height, our z-axis is going to be the radius. And so for each point, we're going to add a vote into that little point right there, that little cube within the cube, right? And then we're going to go and we're going to keep voting all across. And each one of these little cubes, there's 1 by 1 cubes inside of the 100 by 100 by 100 cube, is going to have a certain number of votes inside of it. And the one with the most votes should represent our true center and our radius. So if we did that, then we should end up with something like this. So what we've got here is that 100 by 100 by 100 cube, and it's a little bit difficult to read, but I've got the hot point labeled here in the middle, and it's at 40, 40, 30. And the good news is that's exactly where the center of our first circle was. That's that 40, 40 and a radius of 30. So, so it worked. Now, I mentioned before the yellow shirt. So that could be represented by other pixels here. And maybe my finger might be a little bit in the way or something, and we don't have a perfect circle. And that's actually where this method really shines, is because it's voting, even if it's missing some information, we're still going to be able to find the best circle. And even if there's multiple circles, we're going to be able to detect each of them and find out where the best circles are. So that's what makes this algorithm really exciting and really useful. So all of the code that I use to make these animations and run the algorithm are on my GitHub, which is linked in the description. So if you want to play with it and see how it works, then check it out. Have fun. Have a great day. Bye-bye.